Thanks for coming, everyone. Thanks for being here on the panel. The topic we're discussing is whether it's like a common student question, which is machine learning is super cool, and I'd like to work with it, but it feels like I have to go to grad school to do that. So, A, is that true? And then B, like, is grad school a good deal otherwise? So, to answer this question from multiple perspectives, we have Peter Rabiel, needs no introduction, but presenting the academic perspective because he's a professor, obviously got a PhD. Georgia Yuksari got a PhD and went into the industrial research route, specifically at Facebook AI Research, doing computer vision. Peter Gao did not get a PhD because he joined Cruise Automation, a self-driving car startup, straight from undergrad, and have been able to work on machine learning immediately from undergrad, as far as I can tell, and is currently running his own startup in machine learning. And Anil Jason is received his bachelor's from University of Illinois and co-founded a startup called Quillbot, which is using pretty cutting edge machine learning for improving people's writing, and also did not get a PhD. I'll call on people just so that people aren't speaking all in one. We'll start with Peter Rabiel. Do you think that in 2021, a good undergrad has to go to grad school to work on machine learning? What are the parameters there?
I think there's a lot to consider there. What does it mean to work on machine learning? I think one way to work on machine learning is to kind of just slam things together that are out there and get it up and running. And other things is to like invent new things. And when you invent new things, there's also the notion of what should you even try to invent. And so I think depending on where you want to be, it might be more needed to do a PhD or not. I think PhD is especially good at preparing you for the right questions to ask. Like, what problems should we even work on? What's going to be a new direction we should research? Now, I think it's also changing. I mean, what you alluded to, Sergey, back 5 years ago, as an undergrad, you could go straight to industry because they had nobody they could hire. There was no choice. There was no PhD students available. So they hire whoever they can get. And so I think it'll continue to shift over time. The industry will prefer to hire more experienced people and not have to train them, because I mean, in some sense, industry just costs them money to train people. It's cheaper to just hire them once they're already ready. And so I think there's definitely a shift from the time where, we just have to train them ourselves because there's nobody available, to maybe there's a bit more people available. We can just hire people who already have been trained. So I think that's definitely a trend.
Georgia, you want to take a stab at the question? Like, you can draw on your experiences with like interns you've had or people you've helped hire and so on.
Yeah, I mean, I like the second Peter's opinion that it sort of depends on what you want to do and what it means to work on machine learning. If you want to be in the innovation route, doing research, like what Peter said, what questions to ask and how to proceed and how to answer them, then a PhD is very much valued from a company perspective. And that's likely not gonna change or shift the other way. So a company will like to invest in people that have PhD that are trained to do this. But that's not the only role that is in industry to do machine learning. So there's other routes working on more products. That's something that you just have to have any machine learning experience and most importantly, passion for it. And the other angle I'd like to bring in, which is something that we keep seeing now that we have a lot more people working on machine learning, either from a PhD or fresh from undergrad, is that it actually matters that you are very good at it. We still don't have a way to measure that, but we try to assess. But showing passion and showing that you like it, that you're good at it, and that you have hands-on experience will also matter more and more.
And Peter Gao, do you want to go next?
Yeah, just to set things straight up front, I think there's a unfortunate name collision, so just refer to me as Peter Gao from now on, and that should be easier to differentiate us. In my opinion, I think Peter is correct in that there are different types of what it means to do machine learning. And if you are basically just slamming things together to get something working, you do not need a PhD. I think if you are the sort of person who works at a, say, industry research lab or at like, you know, a very difficult sort of problem domain and you're kind of doing like cutting edge stuff, you will need the PhD or a lot of experience in modeling to do the right thing. But I think the way that ML is going is kind of the way that web development went in, like, you know, say late 90s, early 2000s, where it used to be you needed to have like a PhD in distributed systems to get things working at large scale. And increasingly, there was just a lot of tools and infrastructure that are being built up to the point where you can kind of like import, you know, scikit or something and get something pretty good working. And at that point, the more important thing is just about having really strong software engineering skills and having really good intuition of how to work on applied ML problems that does not require a PhD. It more is like, you know, maybe a master's or maybe like taking some like undergrad courses and doing a lot of Kaggle or something like that. So that's my take.
And then Anil.
Yeah, I mean, it really, to me, depends on the purpose. Like, it depends on your passions and risk tolerance. Ultimately, you probably should know exactly what you prefer and how you study and what you learn better and faster. And if you kind of are more obsessive towards like the architecture, towards the beauty of machine learning intrinsically, getting a graduate is what I would probably recommend, because you just get a much wider perspective on the entire field. That being said, if you're more tactile, if you prefer product and you prefer just getting market feedbacks, I would say that you probably don't need to go to graduate.
So to follow up on that, in your work on Quillbot, you guys are doing some pretty impressive machine learning. And you guys can check it out, quillbot.com. How far have you been able to go, I guess, without like, I think you've hired some, PhD graduates to do some machine learning, but you've also, I think, seemingly got pretty far without them, and also on your own. So how have you, how has your experience been learning stuff on your own and kind of like shipping stuff on your own versus working with people who've done it in grad school?
Yeah, I think what we succeeded in is finding a task that at least the market didn't really predict. People, essentially our user base did not really care that much about quality as much as people would have initially assumed. There's kind of a low bar where you can make the system, or at least, the paraphraser, essentially be useful, but not necessarily like, it doesn't really interfere with their workflow. And really just getting a good intuition on exactly where that, because essentially the market kind of has its own activation function. Once you reach like a certain level of quality, you get like certain adoption. And really just kind of discovering those areas where the proficiency is right at that critical point where it's now implementable and scalable is kind of where I think we kind of got lucky on. That being said, there's so much ripe measures of opportunity everywhere. Like, so.
Cool. Well, I'm going to open it up to the students to ask questions. And, I also have some of my own, but you guys have any questions? There's a question about whether an undergrad or a capable person working on PhD level problems would be judged on the merit of what they're working on or on the fact that they don't actually have a PhD after their name.
I would advise folks not to think about the PhD as like kind of like a line item on your resume, as much as like training that gives you some set of skills that can also be accumulated in different ways. But like, when you are looking for someone to hire onto your team, you're not evaluating them purely based off of like they got a PhD, right? You're evaluating them based on like their ability to like, problem solve or to understand the literature or to like, directly implement things. And, the PhD helps you with some of that, but it is not like the sole qualification that qualifies or disqualifies people from that. It's just like a way to like filter out resumes.
I think, yeah, my take is that it could be more impressive, right, to see someone, because a PhD is also a period of time in which you are supposed to be producing good work. And so if you're not producing good work during that period of time, then that becomes a negative signal, right? So it's like, yeah, you got a PhD, but how impressive really was it? So it could in fact be a negative signal versus maybe you entered a PhD program and then did something like really amazing very quickly and then dropped out. I'd probably prefer that person versus someone who finished a PhD, but wasn't that impressive in other respects. Any other panelists have an opinion?
Yeah, I'll add something. I think maybe, and it ties to the first question also that Sergey had. I think probably the best way to think of a PhD is as a very kind of, let's say, well, unique training position that you're in, that you can find in other places too at times, but it's very hard to find in other places. But if you're lucky enough to find other places, you can get a similar training and get to the same level, and people will evaluate you on what you produce from PhD or from that other equivalent training. And so if it's a typical PhD path, they'll look at the papers you published. Are they at the top venues? Were you one of the lead contributors on those papers, or were you just somebody who's also an author and didn't really do much? Are you publishing really good papers at those venues, or just kind of incremental things that don't really resonate with anybody? But sure, yeah, no reviewer could poke a hole in it, and those metrics don't really relate much to whether you do a PhD or not. But the PhD does tend to put you in this protected environment where you get time to experiment. You get 2, 3, 4, 5 years to just discover what you're excited about, and that can help get you there. But if you just land in another place and you have the right mentor, you might get there just as well, or maybe some people on their own. But I think it's really hard to get into publishing completely on your own. Yeah.
Georgia, what's the experience at FAIR?
Yeah, I think that what Peter said, so the PhD is just a protected environment where you are given time. In industry, when you get in there, either as a research scientist or an engineer, you are evaluated with performance evaluations every so often. So it's a lot more stressful to produce, which is a good thing, but also a bad thing. The PhD gives you more time to explore and to, sort of sit back and think more, develop something longer term. But back to Arju's questions about, how am I going to be evaluated if I am doing some sort of research work but I don't have a PhD? I think that it honestly depends. I think that it depends on the job that you're applying for, the position that you're applying for. But most importantly, what people will look for is not the PhD in the title, but they'll actually dig deep into the work that you have done. So if you have one great paper, even if you don't have a PhD, or if you have 5 very, kind of okay papers, then I think the one great paper will matter more, regardless of titles.
Any other questions from the class? There's a question about how many years in grad school is too many.
I think 5.5 is average. So yeah. What I've heard is 7 and beyond, people start worrying. But a lot of duration of PhD is, a lot of people spend 2, 3, 4 years exploring, and then they find the thing they want to do, and then they effectively do in 2 years their PhD work, right? And so it really depends on how soon you finish your exploration, either deliberately because you say, hey, I didn't find anything exciting, I'll just let my advisor tell me what's exciting and I'll just work on that, or because you just found it and you then went for it.
Any other questions from the students? There's a question how working in industry, someone felt like they spent a significant amount of time just explaining what they did to people who didn't know. And they're wondering if a large part of working in machine learning is just explaining what you're doing.
This is a great point. And I think that stems from like a few things, right? Like one is like whether like your organization is actually familiar with ML or not, right? If like folks there are kind of like say like in an enterprisey environment where like they still don't understand the internet or websites or something, it's kind of a stretch for them to be able to extend that understanding to what ML is, right? Or to understand what it does, its limitations, how it works, that sort of thing. And I think in those sort of environments, you definitely have to just explain what is going on to like lay people, right? But I think, the second point that I'd have is that ML is something that is fundamentally quite new, right? Like even people who have been in the tech field, who've been working on software engineering for a while, just kind of consider ML to be this thing that is still like black magic to them, right? Like they know how to write code, they know how to test regular code, and then you have this completely different workflow with ML that like you just don't really understand how it works or when it works, right? And so like there's still a lot of education there for especially people who don't have like a formal CS education and like say like went to a boot camp and learned how to code that way. But the third point I'd have is that even in cases where you have people who understand the domain, who understand the workflow and the sort of implications of that, you actually still have to explain what the impact of this like ML stuff is on the business, right? Like, let's say you have some model and you present it to your boss and it's like, it's at 90% accuracy or like 90% F1 or something like that. They're like, okay, great. Like, so what? What does that mean for me, right? Does it make me more money? Does it like, lose me money? Does it like, prevent me from having some terrible scenario happen? Does it like, pick more boxes more easily? Does it make my customer happy? Like it's hard a lot of the times to kind of connect like, okay, I made this metric on my test set go up by like, 1% to like, what is this actually doing for the organization? Or like, what is it doing in terms of the impact and why should we continue to invest in it, right? So
Yeah.
I think like that becomes something where it depends on your circumstances, but like a lot of your job in like an industry environment is definitely to not just build the thing, but also to communicate how it works. And that's why so many people go into management.
Yeah, that's a great answer. I have a question specifically for Peter Abil, which is, let's say someone does think they want to go to grad school. What are your like the condensed advice that you give to them? Like, what's the best way to get into grad school? What's the best way? What's the best way to take advantage of being in grad school? What's the optimal path?
Yeah, I mean, a lot of people have different opinions. I think one of the unique things about grad school is that pretty much every professor at every university runs their own show in their own lab, and it's quite different. So, so the first piece of advice would be, if you're going to land in some professor's lab somewhere, and that's going to be the most important decision you make in this process. So for undergrad, you mostly look at schools, and you say, which school am I going to? And schools still matter for a PhD for sure, but within the school, it's really the professor's lab that you're in that plays a much bigger role in your experience than the school as a whole. And so as you think about grad school, somebody who's ready to apply for grad school or feels ready should start developing a sense of what are they excited to work on? Who are the professors leading the labs that do that work? And see if they're excited about the papers written there, and if they extrapolate to the future, what might come out of those labs in the future. Is that exciting? And is that so exciting to you? Like we said, Sergey, if somebody wants to go to grad school, what's the first thing I say? I say, are you really sure you're excited enough to do this? Because you pay a high price along many axes, and you go to PhD at least. You're spending 4 or 5 years working hard, really in most labs, working really hard, harder than most industry jobs, maybe not like founders of a startup, but working harder than most kind of big company industry jobs. And you're not really getting paid much. You can barely make ends meet. So you got to really do it because you love what you're doing every day, and that you have some topics you're really passionate about. And so that's really the starting point. Maybe you really want to be a world expert on NLP or something and invent the next generation of NLP systems. Yeah, that might be a good motivation. But if you're just like, AI seems kind of interesting, I probably should go do a PhD, then I would say probably not. You need a lot more motivation and excitement around what you're going to be doing than that. Not to mention that after you work on something for a half year, you submit it to a conference, and a high chance reviewers say your work is not interesting, and now it doesn't get published. And now you feel like you worked a half year, and you just all your work got rejected by these 3 people who you don't even know their names, but they have all this power to reject your work. So anyway, I think you need to be really passionate about something to want to become one of the world experts, leading experts on the topic, and find the labs that work on this, and then find the way to those labs. And I think that's the other part of your question, Sergey. How do you get there? I think you often cannot get there directly. Like imagine you identify, I don't know, maybe identify Jitendra Malik's lab where Georgia was. Well, if you're already at Berkeley, then there might be a way for you to get there, and you might be able to go talk to the students and see if they take any undergrad researchers and so forth. But if you identify a lab at another school, it's very hard to get involved. And so then you typically want to look in your own school, what's the most similar lab? And is there a way to get involved there and work your way that way to get a strong application?
And then once you're in grad school, what's the best way to kind of progress through grad school? Is it wise to go as fast as possible, or should you like try to spend exactly 5.5 years?
Maybe I'll first defer to Georgia for that, because she's done it more recently than I have, and curious what she has to say. But I'm happy to later answer too.
Okay, so how to proceed through grad school? I think that this is, everybody had a different journey, I feel like. Personally, it took me 2.5 years to finalize and decide what I want to work on and what I am excited about. And after that, I started with the more serious like paper writing, pushing the state of the art in that particular problem. But I did spend the time initially to study exactly that problem and understand everything. And this is where the advisor role was extremely important, because that was encouraged by my advisor at the time, which I really like. Other people have a different style. They like to, just dig into different topics with exploring different directions. So I don't really have I think it depends on, I think you can be successful in many different ways as long as you identify what works for you.
I can give the pitch for industry. I don't know, or we can just keep going with the questions. That's
I'm curious about the pitch for industry. Yeah.
Let's do it.
Yeah. So the pitch for industry is kind of like different tiers, right? I think one route is to go and do a startup, either as like a founder or as like an early employee, right? Another way is to go for like, a unicorn style company, or like even bigger to something like FANG. And then you have like, of course, grad school and all of that. And the thing about industry is that, of course, like you're most likely going to make more money than you are in grad school. The question of like whether like your learning is as high, or whether your work-life balance to compensation plus learning ratio is like as good, is definitely not going to be the same. But I think like my sort of take is that there's kind of a difference between applications and research, and that kind of like crosses the boundary of like industry and research. Like you can go and find jobs in industry where like you're doing research, right? You go to like, say FAIR or Brain, you can do research. And then, there's also companies where like, for example, like you can get an internship there as an undergrad, and you can go and do pretty interesting research work if you're well qualified for that role, or they let you do it. But I think the thing that drove me to industry that I think, is kind of like a mindset thing, is that I had the same decision of like, do I want to go and do a PhD and get into sort of like the deep, like, I would say like, state of the art of like what is possible with like computers, right? And my feeling towards it was like, number one, I'm not smart enough. Number two, it's like quite a bit of time. And number three, it's something where it didn't interest me as much working on something that felt like kind of like a small problem that was like a little farther away from reality. Whereas like going to industry, you have like a lot of ways to basically like take things that people have proven to work already. That sort of like trial and error process has mostly been done for you, and you can apply them to things that are actually more interesting, or like in the sense of being able to solve like practical problems that affect people. And for me personally, like working in a startup, you just learn a lot from going and like doing a lot of stuff yourself and building things, and seeing kind of the feedback between the things you build and like the person that you're building for, or like the segment that you're building for. But the flip side is that you're not going to have as much time to do deep focused work into a single thing. Most likely a lot of your time in industry is going to be, at a smaller company, like hopping from like one problem to another, one fire to another, or like building out basic infrastructure. Like, you're going to probably end up doing like 80% DevOps to 20% modeling at like most like, industry ML shops. And even when you get to like a bigger thing, like, a lot of the times your job at a medium-sized company doing ML is ripping off things that you already know work because you read the paper and saw the benchmarks, and just applying it to a new problem domain and having the intuition to kind of like set up and iterate on that system. Whereas like, there are comparatively few jobs where you're, say, like tackling a new model architecture, or like formulating a problem in a new way, or kind of stretching the bounds of what are possible. And those are usually concentrated within industry research labs. And so like, I would say if you are trying to choose between research and applications, think about like, what you like more on the day-to-day, but also like what you value. And in my mind, what I valued was like getting something that would affect real people on a fairly short timeline. And you learn a lot, but you just learn in a different way. That's my pitch.
That's perfect. Let's go until 7, so 9 more minutes. I'm curious. So Georgia, you've done research in both an academic setting as a grad student and in an industrial research lab at Facebook. What are the differences between the two settings?
The difference is you're driven by the same motivation that you're driven. So I was going to start with what's the same. So the same is motivation. You have exactly the same incentives you have grad school. You really want to push the state of the art in a particular problem. Let's say I work on recognition. That's object recognition within computer vision. So we really want to push that frontier. We really want to explore how to make object recognition better. So you're driven by that exact passion. Now, what's different is, there's many things. So first, you're more, you're grown up, you know more things than 5 years ago when you graduated from PhD. You have more collaborators of a mix of a background, which is fantastic. You have engineers that you can work with. You have more senior people that you can work with. When you're a grad student, you tend to work sort of on your own as the first author. But in industry, you can have more and bigger collaborative projects. And I know that about PhD, that depends on the lab, but in my PhD, I was working as a first author mostly. And I think what the biggest difference, of course, the evaluation. So the way that you're evaluated every 6 months, that actually plays a big role in researchers' day-to-day and how they're structuring their work. So that has pros and cons, depending. I mean, this is a bigger discussion that we can have, but maybe not now. But yeah, the rewarding system basically in industry is different.
All right, thank you. And Anil, you're the only one here who founded a startup straight from undergrad. What was your decision process like? What other alternatives were you considering? Were you considering joining a company or applying to grad school versus starting a startup?
Straight into industry, like working at a big tech startup or big tech company like Google, something that's very secure, very like easy, or just like really, I guess it was just me trying to see to what extent I can test myself in a very, very aggressive, like no going back kind of way. And in that respect, like I wouldn't really wish that on anybody. I honestly would like seriously say like, equal like getting a grad, that is not a recommended course of action and extremely like, risky. So I don't think what I did was particularly logical, so nor would I advocate on it. So I guess that's kind of it.
I think that is pretty common among startup founders to like, feel like you have to do it, and it's like not the right thing to be doing, but like you just have to do it. So, another question, maybe the last question, is for people who are not current undergrads, but there's a larger audience to this course, and a lot of them are practicing software engineers. A lot of people who are maybe pretty senior, right, in their career, but became interested in machine learning and want to get into it, start working on the kind of more problems that they consider more interesting than their day-to-day job usually, or has become. What advice would you give to seasoned software professionals that are looking to start doing more machine learning, if you have any advice?
It's not as hard as you think it is. I think it's like the biggest thing. I would say a lot of times you just have to go do it. One of the best ML engineers I ever worked with was someone who became he was like a software engineer at Microsoft back in the day, like 2000s, got to like principal engineer there, retired, spent 5-10 years as a screenwriter, like a movie screenwriter, and then got interested in deep learning, and then just started like playing around with TensorFlow and trying stuff on Kaggle competitions, and I think he wrote some blog posts and did some side projects, and he was one of the best people I ever worked with at Cruise. And really the main thing that matters there is the time and seat of just trying different machine learning problems, seeing what works, seeing what doesn't, understanding best practices and tools, and just getting some time to work on it, right? It's almost like, going through a boot camp of your own, self-imposition to go and try this stuff. But I would say that, the thing that you kind of unfairly get when you go to undergrad and maybe graduate school is the theoretical understanding of how things work under the hood. And that's often very difficult to learn by yourself outside in industry, because you need a lot of deep focused time to do derivations and understand the math and all that. What you can understand just from doing yourself on the nights and weekends is the overall flow, the intuition, the project management, and the best practices. And that's often enough to get you to be successful in an applied context. So I would say you just need to go do it.
Georgia, at FAIR, is the pipeline purely through academia, or do you work with people who are transitioning from the software engineering side of things into research?
You mean who works at FAIR, who we do projects with? It's a mix. It's a mix of PhDs and a mix of engineers. Usually, and we all work together in projects, and we try to distribute work based on everybody's strengths. We currently don't have a transition pipeline where somebody can become from an engineer to become a scientist. Though I wouldn't be surprised if that changes in the future, because a lot of the engineers that work for many years with us basically end up getting that exact experience to be able to sort of lead and innovate and do exactly the same stuff that scientists are trained to do.
And I think Google Brain is a little bit, they try to funnel people from engineering into research a little more aggressively. Is that right?
That is right. And also, in addition to that, there's also the residency program where that is students that don't necessarily they can come from whatever background, and they come at these industry labs, and they are getting their research experience working with scientists and engineers. And I think that that's another sort of path to get more into research.
Cool. All right, Anil, you want to try one more time?
Yeah.
Oh,
Can
it
you-
worked.
Okay, cool. Yeah. Yeah, just to revise my pessimistic statement. I mean, I do think like the entire process, although it was extremely painful, I think the best learning experiences are kind of painful in nature. And I don't think there's like a curriculum that could have been crafted for me for that particular experience, because it really is like self-adapting and, you know, kind of like a general like search effectively as to what you can and cannot do. It's really hard to like give like a fine-tuned like explanation of what to expect if you were to like do my situation, because I mean, there's no way to model it as far as I can tell. It's really dependent on you, but one thing I would say is that you will learn for sure.
If you do a startup.
Yeah.
Agreed. Okay, well, that's 7 p.m. I'd like to thank Georgia, Anil, Peter, and Peter for being here. And if you guys have more questions, just drop them in Slack and maybe we'll get them over to the relevant people. So thanks, everyone. Have a good Tuesday.
Thanks
See
for
you later.
hosting,
Bye.
Sergey.